So what I was actually trying to show is that um, I was actually trying to I was actually trying to show you what the mathematics behind the percentage change, and then the fact that we have you know functions and methods already existing in pandas and in Python for you to do those things. But it is good you know what is happening behind the scenes so that if something is not going on right, you can correct it and you can understand what is given to you if nothing, if there is there is an issue. For example, we see none here. If you understand the formula, how it works, you would understand why the stat has now or 2020 has now. Because change is when you move from one place to another. So if you are at one place, there is no change. So if you subtract 2020's value from 2020's value over 2020's value, say the 2020's value drops at 2020, yeah, it was here 75, right? So if you subtract 75 from 75, that's going to be 0, and then divide by 75 is going to be error. No, you cannot divide 0 by a number. So a number other than 0, so it's going to give you error, and then that is why we see NaN. NaN is to say not a number. It means not a number, meaning it doesn't exist. So with us seeing that, we went further to plot the growth, and then we saw that 2021, channel like transitioning to 2022 saw a massive over 600% growth. Although 2023 also saw growth, but it is actually a growth in a decreasing order. What we mean by that is that the growth in 2022 was actually higher, more than two times, almost three times higher than that of 2023. So although there are jobs, there are the jobs are increasing, but they are increasing at the increase or the growth from 2020. So when you check from 2020 to 2023, you would say that there is a decrease. But in all, there is an increase. There is a growth at a decreasing rate. So meaning that although there is additional job, but it is more like when you compare it with the previous, it is more like some kind of small. So it is like saying a student, let's pick a university student whose previous ac- semester score was maybe you had an average of 80, that was say first class. If this semester you have 77, it is still first class, but you did, although you did better the same, but your previous sem's average was better, than this one. You might grow, but it is growing at a decreasing rate. You didn't grow. It's not like you are not going up, up, up. You kind of going up, but you've come down small in a growth. In terms of growth, you've come down a bit. I don't know whether that makes sense. Like, yeah. So we know that df dot columns give us a column. When you do the dot column attribute, it's actually going to give us um, a list of all the columns or the variables in the data set. Now, this is an attribute. What is the difference between an attribute and then um, a method? A method is just a function, but a function which cannot stand on its own. So a method always ends with a parenthesis. An attribute does not. That is the distinct difference between that. So now that we've explored, let me even run. Let me even run all of them because I kind of so I'm running all of them, and so let me finish running all of them before we, we continue. So now we know that, let's go check the columns of. So when we look at the columns, we've explored the work year, that is the years of the work, and then we now come into experience level. So let's kind of explore the experience level to see what is there. So what I'm doing is I'm just trying to visualize the experience level. The experience level once again, the level of experience in the job, whether it is um, whether it is a senior level, is it an entry role, is it a managerial role, or is it a mid-level role? So what we do is, remember the dot count value method. And I said that what it does is that it's actually going to, before that, let me even create a cell up here. It is actually going to count, the number of times a particular unique value occurs in that particular variable. So when we look at, so when we do that, you're going to see that if you look at, um, so we look at the experience level when we do the dot unique method, we see the unique values in there. You can see that we have four of them, which is actually SE for senior level, we have the MI for mid level, you have EN for entry level, and EX for executive level. And how do I know this? It is in a data dictionary I added to the folder I sent you yesterday. So if you don't understand anything about the data, go in there, read about that, and then you will be okay. So now we have seen, we know unique actually tells us the unique values in there. Now, if we want to know the number of unique values, we don't do unique, but we do rather n unique. So we just add n to the unique, put n in front of the unique. So n unique, meaning the number of unique. So n unique method actually tells us the number of unique values. So you can see that we have four because we have SE, we have MI, we have EN, and then we have X, EX. That is, we have entry level, mid level, senior level, and then executive level roles. So we have four distinct, experience level of jobs. Yeah. So you just saw another method. You can add it to your toolbox. Now so when you do the value counts, on it, we actually see the value counts. You can see that the senior level roles are actually the highest. They are the most with 5,000, over 5,000 jobs. And then mid level is actually 1,000, over 1,500. And then entry level is over 400. And then that of executive level is the smallest. Now, I don't want it to be this way. If I want to sort, let's say we want to plot, let's just plot, and then let me use kind. You want a bar chart, dot guide bar. Now we can see that it is kind of like in descending order. If you can keep it like this if you want, but if you don't like this, what you have to do is to actually, before you plot, you sort the values before. So we do the dot sort values, and you know that if we do this, then it is going to actually sort them in ascending order. That is the reverse of, and it's going to be how we want it. And if now I plot, then I'm actually going to get it in the ascending order. If that is what you want, fine. If that is not what you want, it's fine. There is no problem at all. Yeah. So this is what we just did here, but you can realize that here I didn't use the kind one. I used a dot plot dot bar. That's fine. We can also say no, we don't want a vertical bar chart, maybe a horizontal bar chart will be, and I do by H, and then you can see it's also nice if you want that. Yeah. So if you want that, you can do this. If you want this one too, you can do. Now so this is what we've done here. Let's try to label the charts. It's always good to label your charts because it helps someone to understand. Even you later, you would understand. So as usual, let's label the x-axis, and then so I'll call it experience level because we can see that we have the experience level rules there. Experience level, and then the y-axis, I'll call it say frequency, or let's call it number of jobs. And let me title it. So who can give me a very nice title for this? If you know it, you can just unmute yourself and then you know and give me a title you think will be suitable for this. Who can help us? Oh, Bianfini, can you hear from me? Zainab, can you hear from me? Okay, so Zainab, can you give us a top, like a title? Just guess. It is experience level, so you can talk of maybe distribution of experience level or just experience level, something like that. I just want you to, kind of, I don't always want to feed you with information, so I want you guys to also follow along with something like that. But if you, I feel like you guys don't want to, you have this thing in you that I'm in person McCarthy, something like that. But no one is right. This is not something of right or wrong. It's a matter of giving it. You give it a title you want. Okay, let me. Okay, okay. Graph of number of jobs mhm, against experience level. Okay, so this is Zainab's own. It's nice. A graph of number of jobs against experience level. It's it's what you want. If you want that, that is fine, right? If you don't want that, that's normal, right? So this is perfect. Thank you, Dr. Zainab, for giving us this title. But I would, um, can you minimize this? Can you kind of summarize this for us? I see some uh, words I can actually take out. So instead of bringing a graph, let's take a graph of, because everybody knows this is a graph. So just always don't include things like a graph of, is it, or a chart of, good, something like that. So this is so much better. Number, what's happening? So is yes, yeah, and that should be normal. So we have it. So Zainab, you've seen how we do it now. Like, see now she's not going to make that mistake. She's always going to be perfect at giving title names, titles of charts, because she said it, and I'm very sure she's not going to forget that. Now, let's see. We can see that we have EX. They are kinda, you know, uh, vertical. Let's rotate them so that they are horizontal. So, who can tell me how we can um, what can we use to do that? What can we use to rotate them? We've been doing this when you have the x-axis values and then they are not in the shape you want. If you want to change them, which one do we use to do that? Who can try? So I'm back. I don't know. Today I'm back. I don't know what happened to, yesterday. It's about to start again, but I hope it doesn't work the same way today because I am actually I've fixed that. So I hope it gets better. Yeah. So guys, I'll quickly share my screen again and then we go. I had to quickly switch from Vodafone to MTN because my network was going off again. I don't know, but only God knows. So I hope you can see my screen now. If you can see my screen, please raise your hand. Let me know. Okay, thank you. So thank you very much. Back to what I was saying. I was asking a question about what can we use to actually change the x-axis labels, you know, to make them stand kind of horizontal. If you know, you just raise your hand or mute yourself and speak. Yeah, right. Oh, okay. So what can we maybe PLT dot what? PLT dot what? Oh, okay. Thank you very much, guys. Then that means you understand what we are doing. Yeah. PLT dot x6. And then we set the rotation to um, 0, right? Or so when you set it to 0, it's going to be okay. So you're telling Python that don't give any rotation, so keep the default one, and it is going to give you the default one. Yeah. So now we've known that. Let's go to the next variable, that is employment type. So we're going to explore employment type 2 so that we know which one, to actually whether it is full-time roles which are very much often or something. But now, before I even go ahead, what insights can you draw from here? You can see that most of the jobs are actually senior level and then mid level, and few are entry level. Does it mean we don't have any room for us? Like there is no room for beginners like us or something like that. Now, this is the answer to it. This is a data we queried from a particular site. It can be that on that site, jobs which are posted, yeah, are mostly senior level and mid level as compared to entry level roles. So it is based on it is actually a problem of sampling. If you don't sample well, there's going to be biasness or there's going to be bias. So this one I can see that there is some kind of bias in it. So it is not a worldwide something. It is a job posting platform, and then this is if so when we queried, if the jobs there, most times people post senior level and mid level this thing as compared to the others, then we definitely going to have more of that. It doesn't mean we don't have entry level roles. You can see entry level roles are even higher than executive roles. So maybe we would also explore one day. We would explore another site like maybe LinkedIn or Indeed.com or maybe Glasgow or something like that. Then we see. But we have to know that over the years, entry level roles have actually been increasing. And mid level, we can see that mid level is very high too. Now, mid level mostly require um, experience level between two, let's say 4, 3, 4, 5, 6 years going. Now you know how to get experience needed in job posts later, and this is just something I wanted to say. So to motivate you, don't think enemies behind because everything is like. So now back to what we're doing. So we're exploring the employment type, and then we can see we do the value counts. You can see that FT, which is full time roles, are actually about so about almost all of them are. So I don't know, but my network keeps. Well, I don't know what's happening to me. No, I don't know how to explain. I don't know why the network keeps. Probably, no, we would see ourselves through. So I was trying to talk about the employment type, and then the employment type is actually a type of employment. And according to this dictionary, we have four different employment type. You have the FC for full time, you have CT for contract, PT for part time, FL for freelancing. And I explained them to you. So full time jobs are full time jobs, contract are contracts. Part time is a part time, we know part time. Freelancing is when you're on your own, more like a consultant. We give you job, you do something like that. Yeah. So when we do a value count, you can see that about almost all of them are actually full-time roles. So even before visualizing this, we can say that in data science, most of the roles are actually full-time roles, and contracts. So full-time roles are almost all of them are full-time roles. Now, why this? This is so because companies want privacy. Data science is actually, or data roles are actually very technical. And then because they involve data, it can be customer data or something like that. They want to trust you. So they don't want to just hire people on contract basis or maybe freelancing. But rather they would like to employ you to keep you in the company so that they keep the company secret. Something like that. So that is why we can see that full-time roles are actually more than all the others. Now if I want to convert these numbers we see here, the 7, 9, 3, 2, 18, 13, 11, to you know proportions, I mean percentages. What argument will I pass in the value counts to do that? If you know, you can just raise your hand and I call you. Let me repeat the question. If I want to, right now when I did the value count, we have the count. So the number of times all of them are. Okay. You can see that full-time rows are 7,932. So if I don't want the values bigger, but rather I want the percentages, I can do something to the value counts so that it converts them to percentages. What will I do to the value counts method to get the output in percentages form or in proportions form? Are you there? Guys, are you there? Okay. Okay, Nanamwa, go ahead. Okay, that one is actually, thank you very much. That is superb. But that one is for percentage change. When we want to see the changes per time. right? But this one, I just want to convert them, okay, into, okay, now one dot pct. Okay, so let's try and see here. Is it here? After accounts dot pct. Uh-huh. Is that all? Okay. And I run. Is that all? So now one. So and bright I'm coming there. Let's so times 100. Now one series has no object, has no attributes. PCT. So you come back later. Bright, I think you had this up. Okay. So like this, right? And then we multiply this by 100, right? So guys, have you seen that? So in fact, right, if you were here, I would have given you my egg. Today too, I'm eating a one. I would have given you the egg for free. In fact, two eggs. I have a crate of egg here. I would have given you all of them, but you are not here. So sorry about that. So guys, that is it. If you want to get the values in terms of proportions, instead of the normal count, always pass the normalized equals true in there, and then you get them converted to um, percentages. So it means that the full-time rows are actually 99.4, or like let's say 99.5% of the actual rows, and then the rest are the 0.05% left. So in this way, you can see how severe it is. So we're having jobs, and then one particular category is taking 99.5%. So it should tell you how important it is, and you will get to know the salaries of data scientists and all over the world. So now seeing that, let's kind of visualize it, and then we visualize it here. We can see that almost it has only just one bar. It's not like all of them. The other bars are not there, but they are very very small to be seen. So freelancing, we can see here is just it was around I think 11. So 11, you can see the scale is from 0 to 1,000. So 11 is very minimal. You cannot even see it is mechanism negligible. So now let's come to the job titles of the job titles variable of our data sets. Now, what is the job titles section? It is actually telling us the particular job title. So if I was working in a data field, I was a data professional in the company, what was my title there? Was I called a bank manager? Was I called what and what? So this is very, very important. You should take note of. Data science rules, or titles actually differ from company to company. Some companies call the data scientists. Some companies call data scientists data analyst. Although we have data analyst, it is different from data scientists, but companies just misinterpret them. So you will see a data analyst role when you check the requirements, they have machine learning, all those ones. In that company, it should tell you that it is not the actual data analyst role you do, it is a data scientist, but they call that role data analyst in their company. So let's see the number of the unique features we have in here. So we can see that some of them, or this can also be the different type of professions we have in data science or the data world. So we can have a business intelligence engineer who is basically data scientist. But here they calling you business intelligence engineer. We have a data manager. We have data scientist, that is a citizen or traditional citizen data scientist. And then you can see machine learning scientist. So here, this is a data scientist who is actually dealing more in machine learning. You are building machine learning models all the time, evaluating them and deploying them for them. We have analytics engineer, who is also a data scientist. But here your role is analytics engineer. So you can be a data analyst or data scientist. You are analyzing data all the time. You have data architect, who is like a data engineer. Yours is to actually design the um, databases and stuff for them. We have machine learning engineer. So I am a machine learning engineer. So what a machine learning engineer does is that you build machine learning models. It can range from computer vision to supervised, unsupervised, deep learning, reinforcement learning, computer vision, NLP task. Yours is to, sit down, build machine learning models, and then deploy them for people to use. We have a data engineer who is much concerned about how do we get data, how do we store them, how do we access them. We have data analysts, we have research scientists like I do. So I work for a lab in NDS, North Dakota State University, NDSU, as a research scientist for them. And what I do is, although I'm working as a machine learning engineer, but my role is called research scientist. So I'm a research scientist because I'm helping them provide them with codes for all their research and stuff in data science and machine learning. We have computer vision engineer. This is a machine learning engineer who is basically working on only computer vision in computer vision works. And computer vision is training computers to see. So of self-driving cars, drones, and all those things. Those are computer vision. We have applied scientists. We have a lot of them you can do. So these are all caps you can wear. So we even have machine learning researcher and all those ones. So these are all job titles for a machine learning engineer, right? Or a data scientist, yes. So if you see a job, this is although um, you are doing data science. This is just a learning course, but this is also to tell you, it's teaching you some of the different job titles, how we call data scientists in a lot of in the different companies. So if you see a job which is say applied data scientist, AI programmer, always go in there and see the requirements, and if you have it, you can apply. So don't limit yourself. Don't think it's always about machine learning and data scientist. So you want to see a role called data scientist. It is called differently. It is called different by it is called by different names, or it is referred to by different names in different companies. Yeah. Now let's do a value count on them, and then let's see which ones are actually you know bigger. Now we can see that we have machine learning engineer, we have data engineer as most the top with 1,888 jobs, and then we have data scientist, the second data analyst, third machine learning engineer as fourth, then we have applied scientist, fifth, and then so on and so forth. So you can see that the rest are actually not significant like that. But here we have, let's focus on the first five. So we can see that this is actually, these are the top five rows in there. And then it is very keen we know that. So we're going to explore more into this. Let's see probably the top 10, and then see how um, we can actually visualize it to see, to educate ourselves, something like that. So what I'm going to do is I'm going to copy this and I'm going to convert it. Right now, if I do type, you would see that it is actually series. So I want it to be, I want it to be a data frame. So if I do type, you can see that it's series, right? So I don't want it that way. I want it to be, and I told you what a series is. A series is what you see in here. So a series is actually a data frame with only one column, and then the index are actually, these are the index, but they were supposed to be column like a mask, something like that. Now let's convert this into a data frame. So let me just copy this and then paste it here. If you want to convert a series to a data frame, you can use a dot frame method. And then when we do that, you can see that we have it converted to a data frame, which is very nice. Now let's look at the top 10, you know, the top 10 rules. These are the top 10 rules. If you don't like it that way too, you can still use the dot head method here, and you still get the top 10. So this one gives you the top 5. Let's see, top 10. You can still, it's the same thing. You can see that. But I just prefer it in a data frame form so that it's nice. It's kind of nice to see it that way. So um, you can see that data engineer is the highest with 188, followed by data scientist, data analyst, machine learning engineer, applied scientist, research scientist, analytics engineer, data architect, data manager, research, blah blah blah. So this is very nice, to know. Now you can see that over the course I've been using the dot dot. So you can see I called this particular variable and I used dot value count, and I use another dot to frame on it, and I've used another dot, you know, on it. So the dot 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 you see is what we call chaining, like a chain, a bicycle chain. So chaining is a way of kind of like stacking one function or one method on the other. So I don't want to do it on separate lines. One line I want to do multiple things. So I'm telling, just like we're doing here, I'm telling Python that call this variable for me, and on this variable, I want you to do a value count. After doing the value count, I want you to convert it to data frame, and after that, show only the top 10. You get it? So it is an efficient way of programming. We call it chaining. Chaining as in bicycle chain. Chaining is actually programming where we start things using the dot 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 in Python. So even with this, if I want to plot, I can do dot plot dot bar, and then I have it. Very nice, right? Very very nice, which is very very nice, right? So um, with just one line with a lot of dots dots dots, a lot of chainings, I'm actually um, having what I am supposed to. If I don't want it this way, then it means that I can first call this on one line, and then on the second line, I'll do a value count, something like this. Um, let me try it. Okay. So let me call df. I can do job title, and then when I call it, I'll say that df job title again. And then I do the value counts. Value count. And after doing the value count, I save it in a variable. Then I do convert the variable to data frame, and then do the dot head, and I do the dot plus dot bar. It's a waste of time. It's not a nice way of programming. It shows that I don't know what you're doing. So we need to be professionals. So instead of doing that, I just do chaining. So you see me doing a lot of this. Now you can go to YouTube and watch videos on how to do chaining in data in Python. Yeah. So now I've plotted this. You can see there is this legend here. If I don't want the legend, I want to put it off. I can do PLT legend, and I think it works. Okay, it didn't work. I think I've forgotten. Let's see. We have a legend. I would we would correct that later when we're going on. But if you don't want, if it is here, fine, it is fine. But if you don't want it to, you can actually um, do you can actually do that. You can actually take it off if you want. I would I would show you that later in the distance. And then you can see that we have the columns kind of standing. You can use the dots, what do you call it? The dots X sticks to kind of rotate the the label, the X labels or the ticks if you want. Yeah. So now let's, I think we've explored this very well. It's nice we understand it. Now we come into a new concept called masking. Masking is a way of masking what I mean is masking as someone masking something. So masking is just to say masking is actually how to subset in um, it's actually how to subset in program. What is subsetting? In mathematics, elementary mathematics, when you say something is a subset of something, it is like a smaller portion. You kind of taking a smaller portion from the bigger thing. So we have a class of around 26, and right now we are around. Let me check. We just few here, around 6 or 7 thereabout here. So there we can say that the we can say that now we can say that okay, the 7 people here are actually a subset of the actual class. So a smaller group or a subgroup under a group is what we call, subset. And the act of doing that is actually called masking or subsetting. If you like, you can say it is subsetting. So you can create. Sometimes you don't want to show everything, but some you just want to show a particular, something in the data frame. So to do that, we do what we call masking. For example, when we look at, let's call the DF data frame. If we look at this, we can see that we have work years. Now, we want to show only the jobs which were posted or in which the work year is actually equal to 2020. We don't want to see 2023. We want only the 2020 and see something. To do that, we can use masking. And this is how masking is done. So we just do df work year. And when we do this, you see that we have only the work year. So if we do df work year equal to 2020 and we run, we can see that we have true, false, true, false. So it is true where the work year is 20 is actually 2022, 2020, and it is false where it is not. Now when we have this, to do the masking, so this is actually the condition we give it. We want to say that you can see that it is double equal sign because this is actually the actual equal sign in Python. The one equal sign is actually assignment operator, trying to assign variables to variables to assign a value to a variable. So now, if I have this, for me to get the to pass this, for me to say that okay, hey Python, give me or show the data frame where the year is actually equal to 2020. All I'll do is I have to wrap this in a square bracket like this. So when I wrap it in a square bracket, I wrap it with df, data frame name. So I'm saying that go into the df, show df, but give me or give me the data set whose work year is actually equal to 2020. And if I do this and run, you can see that we have it here. And you can see that here we only have 2020. And it is actually 75 rows. So 75 rows, meaning we have 75 observations of 2020. If you want to verify that, you can go top here, you can go to the top here where we actually visualize it. Um, we did the year, and we can see that 2020 is actually 75. So that is true. Now, let's go back to where we were. Now we've been able to show we've been able to subset only 2020 jobs. And you can see that we have all of them, all of the other variables in there intact and then working. Now, not sometimes you can just do just one masking or give one condition. Other times you can give more than one condition, that is two, three, or four. So we can do that. So we can also say that let's change this to, we can say that okay, Now we want not the work here, but we want to show experience level. We want to see only beginner level jobs. So where beginner level, that is experience level. We want to see that we want where experience level is actually equal to EN for entry level. And if we run, you can see that. You can see this. So this is actually the data set or the subset of you know jobs for only entry level or jobs where the experience level is entry level. And now when you look at here, you can see the kind of salary some of them are taking. So this is a data scientist who is in Europe because the person takes Europe, but and you can see it's GR. So the person is in Germany, right? Or is it Greece? The person is in either Germany or Greece, and then the person is paid in euros, right? And in euros, it is actually 18,000 euros in a year, but the person in US dollars, the person is paid 19,434. But when we come to this person is a data analyst who is in the US, where the person is taking 80,000 US dollars, and then this person is a data analyst also in he is taking 50,000 US dollars in the US. And when we come here, we can see that this is a data engineer. The data engineer is taking 130,916 as an entry level, role. And then it even goes up for some people, and we will see more. We can explore more to see more, and those ones. But I just wanted to show you how we can subset data. We can subset in here the data in what do you call it in Python. Like I told you, we can subset more than one or two. So here we can give one condition or more than one condition. So here you can see that I'm passing two conditions. I'm saying that first, give me job titles. I want to subset job titles, or I want to subset data where job titles are actually data scientists. And also company location is in US. So give me the data which job title actually is actually data scientist, and then the company location is US or the company is located in US. And then when I did, this is what I have. Now we can also do something like I'm trying something. You can say that now let's kind of say that we want, and now before I go there, you can see there is an ampersand sign here. So this sign is actually and concatenation. When you're given two or more, two or more conditions, this joins or this tells Python this one, this is one condition, and you know, and this condition too. So if it was three, I would have probably put another ampersand here and then give the next one, something like that. Now you can see that when you have more than one condition, you put each condition in a parenthesis. If you don't do that, it's not going to work. So to tell Python that do this one first and go to this one. So it is going to evaluate. It's going to give me the job whose job title is actually data scientist, and then the company is located in US. So the ampersand is called concatenation or and. And like I told you before, it is true when Abubakar Siddiq I'm coming. It is true when all the conditions are true. Abubakar Siddiq, now you can ask a question. Okay, that's fine. So um, I was trying to do another masking with you. Now I want to mask. I want to actually subset the data whose experience level is entry and whose salary is actually over 10,000 US dollars, so that I see whether it is possible or something like that. So the first one I have to bring my, so this parenthesis here is going to take my first condition, and then I bring the ampersand sign, I don't want to confuse you. Then I bring a second parenthesis. This is also going to take my second condition. Now let me first start my condition. I want to give, I'm saying that Python give me jobs where the experience level is actually, and you can see that I'm always passing two equal sign. Once again, it is not one equal sign. In Python, two equal sign is actually for equal to, the normal equal to we know. But one equal sign is an assignment operator. Keep it in mind. You can see I don't pass the equal sign in the square bracket because this is actually calling, this is actually to tell Python that I want this particular variable in this data frame. I'm saying that which one I want, the one which experience level is EN. And I'm putting it in quotes because it is a string, you know that. Now let's come to the next one. I want the one in which also the salary in USD should be um, greater than or equal to 3,000. Now I'm using the underscore. I told you yesterday it is like using a comma. The underscore is like using something like this. But this is not accepted in Python. If you want to do use a comma in numbers, you use the underscore. But it is okay if you don't do. It is fine. But I just feel like let me do it so that it kind of makes things easier for me to visualize. And if I run this 1, 2, 3, boom, I don't get an error. Hey, I'm happy. So we can see that actually 151 out of the 421 rows, actually 151 out of the 429 entry level rows actually have, you know, salaries above 100,000 US dollars. That is 10 billion or around 11 billion, old currency in Ghana in a year. So people are taking close to 1 billion in a month. So is someone asking me a question? Okay, okay, okay. Yeah. Or it will be possible you can save it in. So for example, thank you for that. I thought, yeah, 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 trust our level, but thank you for reminding me. It's a very good thing. So I can store this in a variable, let's say D. I'm just calling it D. And if I do, so this is a data frame, you can see that. So if I do type D, you can see that it's a data frame. And since it's a data frame, I can actually do dot head and then I get it. I can do dot tail, get it. I can do dot info, I can do dot shape. You can see that it is 150. Now there is a new method called sample. So what sample does is it's actually going to sample, it's just like head, but it is randomly going to select number of observations. It's not in order. So we choose a BR. So if you don't provide anything, it selects only one. The default value is one. But if I say five, it will randomly select five observations. You can see that I select the first one is the 1,418th, indexed one. This is, so you can see they are basically random. They are not in order. So if I rerun this, keep an eye on the indexed. You can see that they change. So when you want to randomly select things, you can use the dot sample. If you want to see the first eight or first n observations, You can use if that is in order, then we can use the dot head, last observations dot tail, something like that. So you've seen another method. This is called sample. So right, thank you. We can save our mask. We would obviously be doing that, in the previous system. So don't worry about that. And thank you for giving us that. Um, that's very cool. So we can see that this guy is actually working in an entry role, which is research scientist, like mine here. But he is making 250,800 US Barack Obama dollars, and he is in the US. The company is based in US. That is awesome, right? And the company is medium. It's awesome, right? So you see, there is potential. If I move to US, I'll make much more money, right? See, guys are chopping millions, and I'm here. I'm broke. So it's a motivation for all of us. I chose this data set because it is both educational and then motivational, right? So this is what um, we are actually encountering now. I think it's very nice. We've learned about masking and we've done some analysis too. And I wanted us to continue further. But before we go, let's try to explore the salaries in um, USD, the US dollars. So I do DF. Here you can talk. Okay, thank you. Before I can answer your question, Jonathan said, can I say the masking or subsetting is like filtering? That's it. So the masking is just like filtering. So when you want to filter something, you kind of, you filter and then you get what you want. So you can call it filtering. It's filtering, literally filtering. Yeah. So Jonathan, thank you for that. Um, Back to right what you say. Before I answer, I want to ask you, where do you want to, go to? Where do you want to head to? Maybe you want to head to Lagos or Abuja or something like that. Okay. So the whole point is, even with this one, you bear with me that you really, most of you are struggling to get things right. So I can just come and then we actually doing exploratory data analysis. We're doing ED. If you've really followed what we're doing, we imported the data and we did data validation, and then we come into exploratory data analysis, and then you can see that we're picking every variable and then we explore it. Now I want to kind of give you overview of how data science is like, so that when we start we pick an actual project and we start from importing the data, cleaning the data, pre-processing, validations and exploring the data to maybe building models or maybe communicating findings, you wouldn't suffer. If I start with it right now, most of you will get confused So I have to introduce you to some of these things. You know that okay. So when we start something, you know that okay, if I have a categorical data, this is how I kind of exploit. This is how I validate data, and this is how I can do this analysis and stuff before I give you, any other thing. And mind you, we're not doing actual. We are not learning for exams here. We're learning for understanding. So we kind of explore things. This is we're doing some basic, for me, this is very basic. And these are some of the things we're going to put together. But this is actually in order. If you've forgotten, you can go to the data science process, the particular first lecture we had, that slide I dropped in. You can check the data science process. You will see that we're following exact same. So we are in order, we're heading to somewhere that is machine learning, you know, but we cannot just pick one day and I come and blah blah blah. That is why I'm spending much time because these are actually the most important thing. Data scientists spend more than 80% of the time trying to clean and understand the data before you can actually go into model building or something like that. But if you don't understand the data, then it means you've not understood the problem and you cannot solve it. So this is more like exploratory, we're just playing around things. And I hope you can derive some meanings from it. You should kinda, visualize, kind of make meanings from all the charts we plot in the models and try to ask yourself, so all these things, what can I, use them for? Try to connect the dots yourself. And that will make you the good data scientist. So that when we start things along the line, you wouldn't fumble. I don't know whether I make sense with this. You're welcome. So I was trying to visualize the salaries and then so if I do dot paste because see we can see how the distribution of the salaries. So we can see that the salaries start somewhere around here. We can see kind of hit around 100,000, 200,000. Only a few tick, above 300,000 or is it 250,000. So now before that, let's even try to print. Let's know the minimum and maximum salaries. So we want to know. So for us to know the minimum salary, we use the dot main. Let's say minimum salary. um, um, we call this maximum salary is going to be max. If we run this, you can see that the minimum salary is 15,000 US dollars, and then the maximum salary is 450,000 or 450K in the data set. So what this is telling us is that the minimum salary we can kind of see even in Europe and all those ones, the minimum salary across the world data science role is 15,000. And obviously it's going to be an entry level, but the maximum it can go around 450,000. I know people taking close to a million, taking over 500,000, people taking 600, 700,000 in big companies. But it's more like, this makes sense. And then we've seen the distribution. You can see that a chunk of the data or the salaries actually lie between 50,000, which is somewhere around here. Let me try use my tool now. So around somewhere here, oh, around somewhere here. Let me use red. Red is easily seen. So we can see that the salaries, chunk of them are actually around here and then around 250,000 to my lines are not straight, but forgive me. So most of them are actually here. They fall in this particular category, and it makes sense. So you, what insights can we draw from it? We can see that data science rules actually pay well, and then the minimum salary in a data set is just um, 15,000, which is around. So if you convert 15,000 divided by 12, and you can see how much this person makes in a month. And in the subsequent classes, we would explore to know who exactly makes the 15,000, and we can even explore it now. I'm aware we are closing. We are spending just an hour today. I'm very aware. Myself, I'm super hungry, and I'm going to do one last thing, then we close for today. So don't worry. Right, you go and eat your food. Okay. So let me just do one last thing. So let me do one last thing. Now let's see. We want to know the we want to know the person, or we want to see which particular um, s- work hard, which particular head work hard the salary of 15,000. So to do that, we can use a masking. So we can say that we want the data, the entire um, observations, or the entire details of that particular data, a particular person or particular job whose in salary in USD is 15,000. You can see we have a couple of them. We have four of them, and we can see the first one is actually working in GH. Wow, GH is Ghana. Oh, yeah, GH is Ghana. So we can see that this person is actually working in Ghana, but he's taking 15,000 US dollars, that is 150,000 in um, in a 150,000 in a month, in a year. So if sorry, in a year. So if we divide this by, so 15,000 divided by 12, we have 1,250. So if you multiply this by 11 cities, the person is taking 13,750, and the person is in Ghana, and it is, you can see remote ratio 100, so it is 100% remote. So this person is just like me here, who is working, for a company probably. So let's see company location. Company is also in Ghana. It's making money. So this is a motivation to us that there is companies here making, employing people. And he works as a business intelligence developer, which is a full-time role, and it is a mid senior level, which is just 2022, which is cool. Now the next one is actually NG Nigeria, which is full. There is no remote role, so we work 100% in the office, and the location is in Canada, and then he's also taking 15,000. And we have another one who is a machine learning developer, in Thailand. TH, I think it's Thailand, who is 100% remotely, and then he takes 15,000. The last person is in ID. I don't know whether it's India, it can be Indonesia or something, or India. Now we would, as time goes on, we would actually use some libraries to get, the full names of these ones. We don't need to hard code them. We don't need to think and brainstorm about them. We can see that two of these are actually entry level roles, and makes sense. So data analyst and code. So we can do more explorations and see a lot of, things about that. We can also see the guy who is making that 450,000. Then we just 450,000, and it's one person who is a research scientist in the US. He works fully in office. It is a mid-level, and then the company is located in US, and he makes 450,000. This is crazy, right? So These just few things I wanted us to discuss today. When we meet, probably if we are able to meet tomorrow or not, um, we're actually going to explore more, delve deep into these some of these in-depth analysis. Then when we are cool with this, we take another data, probably in health or maybe any way, and then we do advanced analysis again, and we will see how. Then we pick a project. Remember, we have three projects to complete. So in the next 2 weeks, you'll be doing your first project. So I will give you guidelines. How do this, do that, do that, do that. I'll drop a data set. Do this, do that, do that, do that. And then you do. If you're able to do, then we publish them and all that stuff. So guys, is there any question? If there is no question, probably I want to call it today. Any questions? Okay, Bryce, you can go ahead. Bryce, you can go ahead, please.